Graphing trig functions is going to be your title. All right. All right, so here's what we're going to do. We're going to graph a trigonometry function. We're going to graph the function y equals to the sine of x. Y equals to the sine of x. Well, we know that the sine of a number is some ratio, and we're the opposite of the hypotenuse. And the y now will actually be, what is that ratio? Here's your y-axis, what is the ratio? X will be the angles, the degrees of the angles. Now, let me talk a little bit more about that, because that's kind of the question you should be asking right now, Flotus. You don't have to copy this down, but we're going to punch in 30 degrees, then we'll punch in 45 degrees. This is a 45-degree angle. So 30, 45, 60, 90, they'll go 120, 150, and so on. Actually, we'll just go by 30. We're not going to do the 45 right now. So we're just going to go right alongside the circle. Now, think of the Ferris wheel example. Remember when, if I go up a 30-degree angle, what would the sine ratio be? Well, the sine is if I drew a line right here that's 90 degrees to form the right triangle. Notice the sine of 30 degrees would be this side, right, over the hypotenuse, right? Right, it would be, in this case, it would be x over, I'll put r for the radius, because the hypotenuse is actually the radius of the circle. So the sine ratio would be, it would be, yeah, x over r. So look at the 30-degree angle. It would be this side over this side if it's 30 degrees. How about the sine of 60? Look at 60-degree angle now. I'll draw another line like this, and it would be this side now. It's a little bigger over that side. 90, it would actually converge. Past 90, you're dealing with this. This side over the hypotenuse, right here, if it's at 120. If it's at 150, you're dealing with this side over the hypotenuse, and that would be the sine. Look at opposite over hypotenuse. If it's at 210-degree angle, you're going to deal with opposite over hypotenuse here. So there's a bunch of right triangles formed. You don't have to copy this down because I'm going to go over it more tomorrow. I just want to graph these values right now. So let me do it again. At 30 degrees, what would be the sine ratio? Well, it would be the line that I draw over the hypotenuse, which is the radius. What about at 60 degrees? Well, the sine would be the line that I draw that's 90 degrees over the radius, which is the hypotenuse. Over here, it will be the line that I draw over the radius, which would be 1 over 1. Because here I'm assuming, because the radius and the hypotenuse are actually the same. It would be the same distance. So any number that's the same over itself, if it's the same number, it's going to be 1. So notice how the side that I drew that's 90 degrees, at 30, it gets bigger. And right here, you can imagine it becoming the same as the hypotenuse right here. This side becoming the same, and I kept moving this There's this. It gets closer and closer until this side that I keep drawing that's 90 degrees ends up being the exact same size as the hypotenuse. So it'd be the same number over the same number of its sine, opposite of the hypotenuse. And look over here, 120 degrees. This is 120, but we use this side so that the sine would be this over the hypotenuse again. At 150 degrees, this over the hypotenuse. 210, that over the hypotenuse. 240, this over the hypotenuse. There's 1 over 1 again. 300 degrees, this over the hypotenuse. 330, this over the hypotenuse would be the ratio. Let's see what the calculator spits out. Watch. Let's see what the calculator spits out. Go ahead and put the sine of 30 in your calculator. Just hit sine 30. And what does it spit out? Sine 30, what does it spit out? 0.5. So the first corner should be right here. On a point there. You see that? Because it's halfway on 0.5. How about sine of 0? Can you hit sine of 0 real quick? Sine 0 equals right there. No. We're going to put a 0 here. All right, what was the next angle after 30? 60. We'll put sine of 60. 0.86, a little bit higher. Almost at 1, but about 0.86. This is an estimate right here. After 60 was 90. Go and hit the sine of 90. So here's 90 and 1. Okay. So right now you're just punching these in. The next one is 120, I believe. Yep. The sine of 120. 0.866. Notice how it's becoming cyclical. We've seen that value already. So the sine of 120 right here is going to be 0.866 again. You can start seeing the curve forming now. Sine of 150. 0.5. $180 is going to be 0, I think. You see that? You can see the cycle. Okay. After 180 is 210. What do you got, Perez? Okay, so look at 210 is right here, negative 0.5 now. So that's in between 0 and negative 1. So at 210, I'm at negative 0.5. Or right here. 230. Wait, 210, 240 now.
Negative 0.8.
So instead of positive 0.86, like over here, we're coming down at negative 0.86. I'll put it about right here, almost at negative 1. Not quite there. So that's 240. Now 270 is going to be negative 1. Try punching negative 270. You should get negative 1.
Yeah.
See that? Let's see, 270 plus 300. But 30 is 300, so you're going to get negative 0.86 there. And you can start seeing the wave function coming up. 330 will be 0.5 right here, negative 0.5. So go ahead and you can draw a smooth curve now. This is the sine function. That's the sine function. And it keeps going on forever and ever as the angles get bigger and bigger. It keeps repeating itself. So that's the first trigonometric function you're going to graph this quarter. We'll elaborate more on them tomorrow. I'll keep this up. For now, go on your assignments or any quizzes you owe me. Check your grades too because they're pretty current.